Hello everyone, this is Garrett McGee from Grand Valley High School, and today we'll be talking about quadratic graphs. Now, the first thing that most questions ask for with concerning about quadratic graphs are x-intercepts, which are really just also can be called solutions, roots, or zeros. But all it is when it comes through or hit one of the dot lines, points comes through here, is an x-intercept, solution, root, or zero. Now, when we're talking about quadratics, you can have two solutions, one solution, or zero solutions. And the first one we'll be looking at is a two solution. So our equation is y equals x squared minus 2x minus 3. Now, the first step is to label our a, b, and c. So our a is always with the squared, the b is with a single x, and our c is our variable that has nothing here. So we have a equals 1, b equals negative 2, and c equals negative 3. Now our next step, that's not a good 3, but that's okay. Our next step is to find the axis of symmetry. And this equation is x equals negative b over 2a. And now we simply just plug in our negative 2 there and our a there. So now we just do negative 2 over 2, 1. Now these will cancel out, making this a plus, which is just 2 over 2, which is just 1. So our axis of symmetry is 1. X equals 1. We got to remember that, so we'll box that. And then now we'll go down here and we'll plug this back into the equation where the x's are to find our vertex. So we have 1 squared minus 2 times 1 minus 3. So this 1 times 1 is 1. This will get us, so negative 2 times 1 is just negative 2 minus negative 3. Okay. And this will equal out to be negative 4. So our vertex now is 1 comma negative 4. I'm going to have to remember that one. And now there's two ways that you can do this to get more points. Either you can do the y-intercept, which is just when you have x equals 0, so you just plug in 0 for your x here. And then the other step is just to plug and chuck numbers in into the equation. So I'll be showing both, but the first one we'll do is we'll just do the y-intercept. So you literally just plug in the 0 for the x. So 0 squared minus 2 times 0 minus 3. And now, so 0 squared is 0, 2 times 0, negative 2 times 0 is 0, so negative 3 is what we get for our y-intercept. We get 0, 3 for our y-intercept. Alright, so now we can plot these. So first of all, we'll do our axis of symmetry, which is just 1. There we go. And now we can do our vertex, which is 1, negative 4. We'll do blue. So 1, 2, 3, 4. And now we will do our y-intercept, 0, 3. Negative 3, sorry, there we go. Negative 3. Alright, green. So 0, 1, 2, 3. And when you're dealing with the axis of symmetry, if one's on this side, then the other one has to be on this side. If it's one away, it'll be one away on this side. And now with this, you can simply just, we'll do black, yeah. Simply go up. And that is what our quadratic graph will look like for this equation. Now, this won't be exact now because of you know, if you draw it too wide or if you don't draw it too wide, or however. So to be exact, you can plug in points to find your x-intercepts. Now, just based off of how this is, I can guess that one of them would probably be +3 and -1. Now, if we plug those in, we'll see if we get 0 back, then we will know that they are x-intercepts. If we plug them into the equation. So here, let me clear some space. Here, we'll just clear this out. Okay. Alright, so we'll plug in 3 first. So we get 3 squared minus 2 times 3 minus 3. So we get 9 here. We get -2 times that is -6 minus 3. So this indeed will end up being 0. So that means that that is true, and that is one of our solutions. So we know for a fact that one of our solutions is x can equal +3. X can equal 3. And now we will plug in -1. Plug in -1 to see if that also turned out to be 0 and see if it's true. Alright, so there we go. -1 squared minus 2 times -1 3. -1 squared is a +1. -2 times -1 is all +2 minus 3. This will also equal 0 when we finish this. So we will also know that x can also equal 0, and those are our two solutions for this equation. X can equal -1. There we go. So those are our solutions for this two-real solution problem for a quadratic graph. Now the next one we'll be looking at is a one-real solution. So I'll just have to delete this real quick. And then I'll paste another graph. Alright. Slide that over a little bit. Okay. So now our next equation is, there we go, y equals x squared plus 4x plus 4. Go. Now, like I said in another one, our first step is to find our A, B, and C. So A is always this one, B is here, and C is this one. Like I said, this is also in standard form, but like I said, and then in the application problem, we'll see one that is not in standard form and how to deal with that. So our A is 1, our B is 4, and our C is 4. And then our next step is to find the axis of symmetry, which again is x equals -b over 2a. So now we just put in the 4 there, and we'll put the 1 there. It'd be cool if you could just drag it across, but nope. So x equals 4 over 2 over 1. So we get 4 over 2, which is just 2. So our axis of symmetry is x equals 2. Okay, oops, there we go. Now to find our vertex, we simply just plug the 2 in for wherever we see an x. So 2 squared plus 4 times 2 plus 4. So 2 times 2 is 4 plus 8 plus looks like I made a mistake. I forgot that it's a negative here, so it's a good thing I caught it now and not too late. But I think that's also one thing that you have to realize is you gotta slow down, can't go too fast. So this is actually a -2 here. That one's on me. Even professors as myself make mistakes. You know how it is. So now, so this is -2's here. There we go. +4. Okay. So this is actually a -4. Nah, +4. Just kidding. Plus, no, -8. There we go. Okay. There we go. -8. There we go. Back to that. -8. Okay. There we go. Now we're back on track. Sorry about that one, guys. Alright, so now this will equal, we'll have, so 4's left, -4's here, +4 equals 0. So our vertex is -2, 0. Now we'll do our y-intercept. Actually, in the last time I did the y-intercept, this time we'll just plug and chug on this one. Well, you want to choose ones around your axis of symmetry. So we'll do we'll plug in -3. Here, we'll make a little table here. X and Y. So we know when you plug in a -2, we get 0. Plug in -3. Okay. So we plug in a -3 squared plus 4 -3 plus 4. So -3 times -3 makes it a positive 9 plus 4, or 4 times a -3 is -12, and we have plus 4. So 9 minus 12 is -3, plus 4 is 1. So that is that point. Go. Okay. Now we'll plug in -4 here. Okay. So we have -4 squared plus 4 times a -4 plus 4. It's a lot of 4's there. So -4 times -4 makes it a positive 16. This would be a -16 plus 4. Hold on, let me put that 4 there. Okay. So this will cancel out, and we get just plus 4 here. Alright, so now we can fill in our stuff. So axis of symmetry is -2. So here we go. Alright, our vertex is, do green, -2. Here, just show that. So this is that. Okay, -2 is 0, so -2 here. Now we can plug in -3, 1, 1, 2, 3, 1. And like I said before, if it's on this side 1 over, it'll be on this side 1 over. Now we have -4, 4, so 1, 2, 3, 4, up, 1, 2, 3, 4. So over, there we go. Okay, and now we can fill this out, kind of. There we go. Okay, and now, so for this one, actually is easier because, excuse me, our x-intercept is actually on this line, and it's -2, and we already see that it puts out a 0, so we do in fact know that this is our solution right here. So we simply just put x can equal 2, -2, sorry, there we go. And that is our solution, or root, or 0, or however they want it in there. And now for our next problem, we'll be looking at a no real solution, which is where the graph will never where nothing will ever go through their x-intercept. So I'll just need to clear this out real quick. We'll put a graph down again. Alright, there we go. Okay. Alright, so now for this equation, we have y, oops, I forgot to switch over. Y equals x squared plus 2x plus 2. Like I said, our first step is always to find our a, b, c. Okay, so our a is 1, b is 2, and our c is 2. Now we have our axis of symmetry, x equals negative b. I'll circle that one so I don't hopefully forget this time. Negative b 2a. And now we simply just plug in, so we get x equals negative 2 over 2, 1, so just 2, so we get, it'll be negative 1. So our axis of symmetry is negative 1. There we go. Now we plug in this to find our vertex. So we'll plug in negative 1 there, squared, plus 2, 1, plus 2. So this will make negative 1 times negative 1 makes it a positive 1, plus 2, plus 2. Oh, negative 1. That's what I forgot. My bad. Okay, see, I'm making mistakes again. My bad, guys. So here, let me erase what this is going to be. And this will also change now again. Negative 2. There we go. So we get negative 1 plus 2 equals 1. So our vertex is 1, 1. There we go. And I have been making a lot of small mistakes like this, but it's a good thing that I'm finding them. That's the most important thing, is you can make as many mistakes as you want as long as you find them and correct them. So now we'll do, how about we'll just put in points again. That seemed pretty nice last time. I think when you put in points, it definitely makes your graph more accurate, because especially when you're like me and I don't have any artistic ability, I can't really, I'm drawing like this up here, so doesn't really help. So when you have points though, it'll help you to be more accurate. So here we go, we'll do x and y. So we already know we get, for this one we get negative 1, there we go, negative 1, 1. We'll put in negative 2 and negative 3. Alright, so let's put in negative 2. Negative 2 squared plus a 2, negative 2 plus 2. Alright. We'll get a 4 here, minus 4 here, and a plus 2. So this will just be 0 plus 2 is 2. So 2 will equal, negative 2 equals 2. And now we're going to put in, we will put in negative 3 now. Here we go. Okay. So negative 3 squared plus 2 times negative 3 plus 2. There we go. We'll get a positive 9, a negative 6 plus 2. So 3 plus 2 equals 5. There we go. 5. Now we simply just plot out points like we have been. So this is our axis of symmetry, negative 1. Ooh, yep, okay. There we go. Now we have our vertex, negative 1, negative 1, 1. So negative 1, 1. There we go. Now we have negative 2, 2, so over 2, up, yep, there we go. And then negative 3, 5, so it's 2, 3, 4, 5, there we go. And whatever I said, if this is 1 over here, it'll be 1 over here because of our axis of symmetry. 2 over here, so 1, 2. There we go. And now we just fill out. There we go. There we go. Okay, so that is what our no real solution, which is actually now even easier because it's, you can just tell by the graph there is no solutions because it will never will this graph ever have to come through the x-intercept line ever. So that makes it pretty easy. And so now on to our application problem, which is, here we go, let me clear this out first. Here we go. Okay. Now on this one, you don't really need a graph for this for the question, but so this is what the question says. It says an arrow shot into the air is modeled by the equation y equals, here we go, y equals 96t minus 16t minus 16t. Okay, it says, now it says feet above the ground, t seconds after it is released. Graph the equation to find what period of line the arrow is above 128. Now, this is our A value here and our C value, but we don't really have the B or whatever, but that's okay because we're not, this is why it gets a little, we'll have to do some manipulating later on. But so whenever your A value, or sorry, I forgot to put a T there, my bad. But if your A value has a negative in front of it, then your parabola will be going downwards, which makes sense in this case because we're shooting an arrow, and an arrow is going to start there and go like that. Now what this is asking for is at what time periods or how long is the arrow above 128. So if we logically think about this, an arrow will at one point be at 128 because it'll be going up and it'll be back down at 128. So we're trying to find this time period of how long it is above 128. Now, so we start by plugging in 128 for y and we'll solve for t. I'll put this black, there we go. Okay, so 128 equals 96t minus 16t, okay, 2t squared. Now when we manipulate it around, we can get it to negative 16t, whoops, yeah, okay, negative 16t plus 96t minus 128. So look, now we got our A here, our B here, and our C here. Sorry, I think I said this was C later or something weird, but sorry, yeah, we're good now. So it's our A, B, and C. Now in this one is different because like I said, this is more application. You don't just, you gotta logically think this through also. So, but through this, we can already see that we can factor because all of these work out. So we can factor here, so we can factor out a negative 16 here. So we have negative 16 t squared minus 6t plus 8. Yeah, now thinking about it, t probably wasn't the best exponent to use here with the pluses and stuff, but that's okay. So, and now out of this we can just try and solve here. We can take a t, we'll get t minus 4 and t minus 2. And when you're just trying to solve these to 0, so how would you make a t minus 4 equals 0? You just positive 4 here. So that means t can equal 4. And on the same thing here, 2 minus 2 equals 0. So t can equal 2. So now off of this, we see that when it first comes up, this is 2 seconds of how long. So when it first goes above, it'll be at when it first goes above 128 feet, it's at 2 seconds. And when it comes back down, it's 4 seconds. So like I said, it asks what is the period of the time there is above 128 feet. So it's just simply 2 seconds. 2 seconds is our answer. Okay, and we'll just graph it out here a little more just to help. If it wants to come up, there we go. Alright, so to make it look more like how it's supposed to be, or to visualize it better at least. So if this is our imagine, so don't think about these numbers right now. Imagine this is 128 feet is this line here. 128 feet is this line here. So what we're saying here is he's shooting an arrow here from there to there. And we want to know when it's above here. So this right here would be our 2 seconds here. Now obviously I didn't draw this well, but here I can draw this back to what it should actually look like. There we go. Look, took some of the graph off, but that's okay. There we go. Let me just delete this actually. This graph is, wow. Here we go. There we go. Now we can actually, we'll just redo that because that was going to look ugly. We'll try and make it look a little better this time. Jeez. Alright, so if we're actually going to draw this correctly, so we're saying that at 2 seconds, it's above. So from here to here is what we're saying, is that it is above. If we were to draw a parabola out and say this is actually at 128 feet, so like in previous ones, like I've said, this is two solutions. This is a two solution problem actually, because look at this, we have 2 going through the x-intercept, which is t equals 4 and t equals 2, which is just 2 seconds. So like I said before, this is an applicational problem, which means you got to really logically think through this and not just you can't really just stick to the prompt to say. But yeah, this is Garrett McGee, and this is all I have for quadratic graphing. Went through most of the basics and went through an application problem. So hopefully this helps you guys out pretty well. And if there's any more questions, just comment on what you guys need.